Which of the following functions f from z to z, that is integers, is bijective? We can say that the function f is bijective if f is 1 to 1 and onto. If a function is both 1 to 1 and onto, we can say the function is bijective. And 1 to 1 condition, for x1 not equals to x2, f of x1 not equals to f of x2, and here we can say for x1 comma x2 belongs to z. And coming to the onto condition, for every y belongs to z, there exists y is nothing but f of x. For every y belongs to z, there exists at least one x belongs to z, such that f of x is equal to y. Means y is the image of that element. So let's say the first option, f of x is equal to x power 3. So here we can say that for x1 not equals to x2, x1 cube is also not equals to x2 cube, where x1 x2 belongs to integer, and hence we can say f is 1 to 1. Coming to the onto function, let y is equal to x power 3. So we can write x is equal to y to the power 1 by 3. Clearly we can say that for y is equal to 2 belongs to z, there is no x belongs to z, such that f of x is equal to 2, because cube root of 2 is not an integer. So that we can say that this function f is not 1 to 1. So f is not onto, sorry. So function is f is 1 to 1 but not onto. So first one is not an option. Coming to the second option, f of x is equal to x plus 2. So here also we can say for x1 not equals to x2, x1 plus 2 is not equals to x2 plus 2, which implies f of x1 is not equals to f of x2. So therefore f is 1 to 1. And coming to the onto, let y is equal to f of x, that is x plus 2. So which implies x is equal to y minus 2. So here clearly we can say that for every y belongs to z, there exists x. There exists x is equal to y minus 2 also, which is also an integer, such that f of x is equal to y. And hence we can say this function f is onto. So here this function f is both 1 to 1 and onto, and hence we can say option B. So option B is the answer. Similarly, we can also just count for the f of third option and fourth option. F of x is equal to x plus 1. For x1 not equals to x2, 2x1 plus 1 not equal to 2x2 plus 2, okay. But coming to the onto function, let y is equal to 2x plus 1. We can say y minus 1 upon 2 is equal to x. So for y is equal to 3 or y is equal to 4, so 4 minus 1, 3 upon 2 is equal to x, does not an integer. So and hence we can say third option is not an onto function. And coming to the fourth option, x square f of x is equal to x square plus 1. If you can consider x is equal to minus, for x1 is equal to minus 1 and x2 is equal to plus 1. For x1 square is equal to 1. Minus 1 whole square is plus 1 and plus 1 whole square is 1. So for two different elements minus 1 and plus 1, but you're getting x1 square value is same, that is x square value is same, and hence we can say that the function is not 1 to 1. Not 1 to 1, because x1 square plus 1 is equal to x2 square plus 1. That is f of x1 is equal to f of x2. For x1 is not equals to x2, you are getting f of x1 is equal to f of x2, and hence we can say this function is also not bijective. So only option B is correct. If a row matrix 2x 4 and column matrix x and minus 8, their product is 0, then the positive value of x is, it's given 2x 4 multiplied with x and minus 8, which is equal to 0 matrix. So here we can see the order, 1 row 2 columns, and here 2 rows and 1 column. So we will be getting a matrix of order 1 by 1. So we can write this 1 by 1 matrix as 0 matrix with 0 element. So let us simplify here. Row with column 2x into x 2x square plus 4 into minus 8 is minus 32, which is equal to 0. So equating the two matrices, both are of 1 by 1. So we can correspondingly we can write 2x square minus 32 is equal to 0, or 2x square is equal to 32, or x square is equal to 16. So x is equal to plus or minus 4. And since the question is about the positive value, so we can write the positive value is positive value of x is plus 4. So we can go with an option C. Let A is equal to a 3 by 3 matrix, 1 minus 1 1, 2 1 minus 3 and 1 1 1, and 10 times B is equal to 3 by 3 matrix again, 4 2 2 minus 5 0 A, 1 minus 2 3. If B is the inverse of A, if B is the inverse of A, then find the value of small a. If B is the inverse of A, we can write, and also we have A inverse into A is equal to I, that is B into A is equal to I. So here B is equal to 1 by 10 times of 422 minus 50 A, 1 minus 2 3, and since we know that B into A is equal to I, so we can add 1 by 10 times of 4 2 and 2 minus 50 and A, 1 minus 2 and 3 is multiplied with the A matrix, that is 1 minus 1 1, 2 1 minus 3 and 1 1 1. Let us consider any one row or column so that which is related to A to get the value of A, and here which is equal to I, that is 1 0 0 0 1 0 0 0 1. Just one element if you find, you can get the value of A. So let us consider second row with the first column. Second row with the first column, let us do it this. Minus 5 into 1, minus 5, plus 0 into 2, 0, plus 1 into A, plus A, which is equal to 1 0 0 0 1 0 0 0 1. And here we can say that by comparing, minus 5 plus A 1 upon 10 is equal to 0. So here we can write minus 5 plus A upon 10 is equal to 0, or A minus 5 is equal to 0. So A is equal to 5. So the value of A can be taken as 5. So option A. If A is equal to 2 by 2 matrix, cos x minus sin x and cos x, and given that A plus A transpose is equal to I. Find x when x belongs to 0 to pi by 2. Let's find the transpose of the matrix. Cos x minus sin x and sin x and cos x. Transpose is nothing but interchanging the rows and columns. So we'll get cos x sin x. The first column will become first row and second column will become second row. And it is given that A plus A transpose is equal to I. So we can write cos x minus sin x sin x and cos x added with transpose of a matrix cos x sin x minus sin x and cos x, which is equal to I. Identity matrix is 1 0 0 1 in 2 by 2. So that is 2 times cos x 0 0 2 times cos x, which is equal to 1 0 0 1. When two matrices are of same order, then their corresponding elements can be equated if they are equal. So we can consider here 2 cos x is equal to 2 cos x is equal to 1, that is cos x is equal to 1 by 2. When cos x is equal to 1 by 2, so we can write x is equal to pi by 3 cos 60 degrees, since the x belongs to 0 to pi by 2. So we can consider x is equal to pi by 3. So which is option D. Given if integral e power x tan x plus 1 into secant x dx is equal to e power x into f of x plus c, then what is f of x? So let us consider e power x into tan x plus 1 into secant x dx, which is equal to e power x into, we can add secant x tan x plus secant x dx, and we know that very clearly differentiation of secant x is secant x tan x. So if f of x is equal to secant x, then f dash of x is equal to secant x tan x. So we can write integral e power x times f dash of x plus f of x dx. We know the property integral f of x e power x into f of x plus f dash of x is e power x into f of x plus some integral constant c. So here f of x is equal to secant x. So we can write e power x into secant x plus c. So therefore f of x we can consider it to be secant x, which is option C. The integrating factor of the differential equation 1 minus x square of dy by dx minus xy is equal to 1. 1 minus x square of dy by dx minus xy is equal to 1. So we can write it as dy by dx minus x upon 1 minus x square of y is equal to 1 upon 1 minus x square, just by dividing 1 minus x square. So which is in the form of dy by dx plus p of x into y is equal to q of x. So here p of x is equal to minus x upon 1 minus x square. So we can take the integrating factor of this model is e to the power integral p of x dx plus c. So we can write here integrating factor is equal to e to the power p of x is minus x upon 1 minus x square dx, which is equal to, and here we can substitute, put 1 minus x square is equal to t. So we have minus 2x dx is equal to dt, or minus x dx is equal to 1 by 2 dt. So we can write e to the power integral minus x dx is 1 by 2 dt divided by t, that is into e to the power 1 by 2 integration of 1 upon d is log t. So which is e to the power log t power 1 by 2, that is root t. And we know that e power log is nothing but we can consider root t, that is root of t value is 1 minus x square. So integrating factor of this differential equation is 1 minus x square root. So which is option D. The order and degree of the differential equation y is equal to x into dy by dx plus a times root of 1 plus dy by dx whole square. We can write y minus x dy by dx is equal to a times root of 1 plus dy by dx whole square. Squaring on both sides, we can write y minus x into dy by dx whole square is equal to a square times of 1 plus dy by dx whole square. So here we can say that we have the highest order is 1, dy by dx is the highest order here, which is 1, and the power of the highest order in this expansion is 2. So we can see on both the sides x minus y minus x dy by dx, after simplification we'll get dy by dx whole square, and the right the right side also we have dy by dx whole square is 2. So the power of the highest power of dy by dx in the equation is 2. So we can go with an option, degree is 2. So degree is 2 and order is 1. So 1 comma 2 is the answer, which is option A. If vector A is equal to 2i plus 2j plus 3k and vector B is equal to minus 1 times I plus 2j plus k and vector C is equal to 3i plus j, and A vector plus x times of B vector is perpendicular to C vector, then what is the value of x? So let us consider A plus x times of vector B, which is equal to 2i plus 2j plus 3k plus x times of x is some real number, x times of B vector, that is minus 1i minus 2j plus k cap. We can simplify and write here 2i minus xi 2j plus 2xj 3k plus xk, which is equal to 2 minus x of I plus 2 plus 2x of j 3 plus x of k cap, and it is given that a plus xb is perpendicular to vector C. We know that if two vectors are perpendicular, if a vector is perpendicular to the b vector, then we can say the dot product will be equal to 0. So that we can write a plus xb vector dot product with the c vector here, which is equal to 0. So which implies 2 minus x times of I plus 2 plus 2x times of j plus 3 plus x times of k dot product with c vector. C vector is nothing but 3i plus 1 times j plus 0 times k, which is equal to 0. So let us simplify here. 2 minus x into 3, that is 3 times 2 minus x plus here 1 times 2 plus 2x plus 0 times 3 plus x is equal to 0. So we can add 3 to the 6 minus 3x plus 2 plus 2x and plus 0 is equal to 0, or simplifying minus 3x plus 2x is minus x, 6 plus 2 is 8 is equal to 0, which implies x is equal to 8. So the value of x is 8. So we can go with an option A. If vector A is equal to I plus j plus k and vector C is equal to I minus j, then a vector B satisfying the equation A cross B is equal to C vector and A dot B is equal to 3. So we need to find the vector B. So let us choose the options. So if I can choose the first option as a B, then A is equal to I plus j plus k, and let us consider the dot product. Dot product with 2 by 3i plus 2 by 3j plus 5 by 3k. So this is the first option, and we consider B as a vector, first option. So which is equal to 1 times of 2 by 3, that is 2 by 3, because in dot product we just multiply the scalar components of the I, j and k respectively. So 1 times of 2 by 3 is 2 by 3, plus again 1 times of 2 by 3 is again 2 by 3, and again here 1 times of 5 by 3 is 5 by 3. So which is equal to 9 upon 3 is 3. So a dot b is equal to, so here a dot b, you are getting 3, which is correct. So we can say that option A is the correct one. Let us also verify the other options. Let us consider the second option B. So I plus j plus k dot product with, let us consider this is B, minus 5 by 3 I plus 2 by 3 j plus 2 by 3 k, so that we can get 1 times of minus 5 by 3, and again here 1 times of 2 by 3, and again 1 times of 2 by 3. So it is 4 minus 5 minus 1 by 3, which is not satisfying. So second option is wrong. And third option, let us consider I plus j plus k times of 5 by 3 times of I minus 2 by 3 times of j plus 2 by 3 times of k is equal to 5 by 3 minus 2 by 3 plus 2 by 3, which is equal to 5 by 3, which is not equals to 3. So we can say third option is also it is wrong. So let us go with the fourth option. I plus j plus k times of 5 by 3 of I plus 2 by 3 of j plus 2 by 3 of k, which is option D here. So multiplying, so 1 times of 5 by 3 is 5 by 3, plus 1 times of 2 by 3 is 2 by 3, again 1 times of 2 by 3 is 2 by 3. So which is equal to, you are getting, so 5 by 3 plus 2 by 3 plus 2 by 3, that is 9 upon 3, which is equal to 3. So fourth option is also satisfying. So here two options are satisfied. So option A and option D both are satisfying. Now let us verify A cross B. Let us verify A cross B with the first option. So we have I, J, K, and A is a vector with 1, 1, 1, and B is a vector with 2 by 3, 2 by 3, and 5 by 3, which is equal to, so I times of, using the determinant, 1 times of 5 by 3 minus 2 by 3, that is 3 by 3, and again minus j times of minus j times of 1 times of 5 by 3 minus 2 by 3 is again 3 by 3, plus k times of 2 by 3 minus 2 by 3 is 0, which is 1 times of I minus j. So which is given option, that is a vector C. So we got A cross B, we got it, A cross B is equal to vector C. So we can just consider that option A is the correct one. Option A is the correct one, and we can also make sure that A cross B, which is not equal to C in the case of fourth option. Or let us consider here B is equal to, or let vector B is equal to xi plus yj plus zk, so that A cross B vector is equal to C vector. So let us find the determinant I, j, k, A vector with the components 1, 1 and 1, B vector with the components x, y and z, which is equal to vector C, that is I minus j. So we can write I times of, using the determinants, 1 times of z minus y minus j times of 1 into z minus x, that is z minus x, plus k times of 1 into y minus x, that is y minus x, is equal to I minus j. So comparing the components on both the sides, the vector I component is z minus y and here it is 1. So z minus y is equal to 1, and here negative z and here also negative z. So let us compare. Z minus x is equal to 1. So z is equal to 1 plus y and here z is equal to 1 plus x. And now let us assume a dot b is equal to 3. A dot b is equal to 3. So we can write 1 times I plus 1 times j plus 1 times k dot product with our b vector is nothing but xi plus yj plus zk, which is equal to 3. So that we can write here x plus y plus z is equal to 3. Now let us substitute z is equal to 1 plus y, or we can write y is equal to z minus 1 and here x is equal to z minus 1. So x is equal to z minus 1 plus y is equal to z minus 1 plus z, which is equal to 3. So that is 3z minus 2 is equal to 3. So which implies 3z is equal to 5. So z is equal to 5 by 3. When z is equal to 5 by 3, so y is equal to x is equal to z minus 1. So that is 5 by 3 minus 1, that is 2 by 3. So we can write y value is 2 by 3 and x value is 2 by 3. Therefore, vector b is equal to xi, that is 2 by 3 I, and next one y is equal to 2 by 3 j and z is equal to 5 by 3 k. So which is 2i plus 2j plus 5k divided by 3. So we can go with an option A. Option A is the answer. If a line makes angles alpha, beta and gamma with the coordinate axis in space, then cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to. So x-axis, y-axis and z-axis in space. Let us consider there is a line which makes with an x-axis alpha and with y-axis is beta and with the z-axis say gamma. Then we can say cos of alpha, direction cosines of the line. We can write direction cosines of line are L is equal to cos alpha, M is equal to cos of the angle beta with respect to y-axis, and N is equal to cos of the angle gamma. And there is a relation between this cosine of the angles between a line for a line. So we have L square plus M square plus N square is equal to 1. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1. And subtracting 1 here, cos square alpha minus 1 plus cos square beta minus 1 plus cos square gamma minus 1 is equal to 1 minus 3. Or we can also write, let us leave cos square alpha plus cos square beta plus cos square gamma is equal to 1 and let us consider cos 2 alpha plus cos 2 beta plus cos 2 gamma, which is equal to, by using the formula, cos 2 alpha is equal to 2 cos square alpha minus 1 and here 2 cos square beta minus 1 and 2 cos square gamma minus 1, which is equal to 2 times of cos square alpha plus cos square beta plus cos square gamma minus 1 minus 1 minus 1, that is minus 3, that is 2 times of, since we know that cos square alpha plus cos square beta plus cos square gamma is equal to 1, so 2 into 1 minus 3. That is 2 ones are 2 minus 3, which is negative 1. So we can say that cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 1 when alpha, beta, gamma are the angles made with their coordinate axis in a space. So we can go with an option B. The angle between the lines x plus 1 upon 2 is equal to y plus 3 upon 2 is equal to z minus 4 upon minus 1, and another line x minus 4 upon 1 is equal to y plus 4 upon 2 is equal to z plus 1 upon 2. So we can say that the direction ratios of this line, the first line let us consider a1, b1, c1 as 2 comma 2 comma minus 1. Here we can say direction ratios 2, 2 and minus 1. And for the second line, let us consider a2, b2 and c2, the direction ratios as 1 comma 2 comma 2. And we know that if a1, b1, c1, a2, b2, c2 are the direction ratios of two lines, then the angle between them can be considered to be cos theta is equal to, if theta is the angle between the lines, we have cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. So we can write here a1 is 2 into a2 is 1, 2 into 1 plus 2 into 2 plus c1 is minus 1 into 2 divided by root of a1 square, that is 2 square plus 2 square plus of minus 1 whole square into 1 square plus 2 square plus 2 square. So 2 ones are 2, 2 plus 2, 2, and here 2 twos are 4, and again minus 2 divided by root of 4 plus 4, 8 plus 1, that is 9, root 9 into root of 2 twos are 4, 4 plus 4, 8 plus 1, 9. So we have 2 plus 4, 6, 6 minus 2, that is 4, 4 upon 9. So cos theta is equal to 4 upon 9, which implies theta is equal to cos inverse of 4 by 9. So cos inverse of 4 by 9, which is option D. We can go with an answer D. The line passing through the points 5 comma 1 comma A, say point A, and point B 3 comma B comma 1 crosses the YZ plane, let us say, at the point say P. The coordinates of point P is given 0 comma 17 upon 2 comma minus 13 upon 2. Then find the values of AB. Let us consider the equation of a line passing through A and B points, passing through the points A and B. We have, let us consider to be x1, y1, z1, x2, y2 and z2. So we have the equation x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So here the points x minus x1, that is x minus 5, divided by x2 minus x1, that is 3 minus 5, which is equal to y minus 1 divided by y2 minus y1, that is b minus 1, z minus z1, that is z minus a upon z2 minus z1, that is 1 minus a, which is equal to, let us consider to be lambda. Or we can also write x minus 5 upon minus 2 is equal to lambda, y minus 1 upon b minus 1 is equal to lambda, or z minus a upon 1 minus a is equal to lambda. Since this line is passing through the plane yz plane, so we can write this is yz plane whose x coordinate will be equal to 0. So since this line is passing through the point, so this point must lies on the line passing through the points AB. So definitely the x coordinate will be equal to 0. So let us assume that x minus 5 upon minus 2 is equal to lambda, that is x minus 5 is equal to minus 2 lambda, or x is equal to 5 minus 2 lambda must be equal to 0 since x coordinate will be 0. So 2 lambda is equal to 5. So lambda value is 5 by 2. So we got the value of lambda is 5 by 2, and now the y coordinate y minus 1 upon b minus 1 is equal to lambda is 5 by 2, and also the y coordinate is given 17 upon 2. So we can substitute 17 upon 2 minus 1 is equal to 5 by 2 times of b minus 1, or we can add 17 minus 2, that is 15 upon 2 is equal to 5 by 2 times of b minus 1. So here 5 3 times are b minus 1 is equal to 3, which implies b is equal to 4. So the value of b is 4, and now the z coordinate, let us consider z minus a upon 1 minus a is equal to lambda. Z minus a upon 1 minus a is equal to lambda is 5 by 2, or we can write 2 times of z, and z coordinate is minus 13 by 2. Let me write 2 times of z minus a is equal to 5 times of 1 minus a, which is 2 times of z, that is minus 13 by 2 minus 2a is equal to 5 minus 5a, or we can write minus 13 minus 2a is equal to 5 minus 5a, or we can write minus 13, or 5a minus 2a is 3a is equal to 5 plus 13 is 8. So which implies a is equal to 6. So the value of a is 6 and b value is 4. So 6 comma 4, which is option D. The solution set of the inequation x plus 2y is greater than 3 is, you can just check that with the origin point, substituting the origin x is equal to 0 and y is equal to 0. So we'll get 0 plus 2 times of 0 is greater than 3. That is 0 is greater than 3 is false, which indicates that the solution of the inequality x plus 2y greater than 3 does not including origin point, that is 0 comma 0. So we can consider that the solution set of this inequation is the half plane which is not containing the origin. You can also check in the graph x plus 2y greater than 3, we can write x upon 3 plus y upon 3 by 2 is equal to 1. So we have x intercept is 3 and y intercept is 3 upon 2, and the half plane, the shaded region can be either upper or lower, and here origin is the point 0 comma 0. If we can just verify with this point, since the line is not is passing through the origin, so we can just check with the origin 0 comma 0, and here you are getting 0 greater than 3, which is false, which indicates that our shaded region is not towards the origin, so which is away from the origin, means other half plane. So option B is the answer. The maximum value of z is equal to 3x plus 4y subject to the constraints x plus y is less than or equals to 4 and x is greater than or equals to 0, y is greater than or equals to 0. So let us draw the graph. Since x is greater than or equals to 0, y greater than or equals to 0, which implies the shaded region or the solution is in quadrant 1. So x plus y less than or equals to 4. So we can write x upon 4 plus y upon 4 is less than or equals to 1. So we can have the intercepts, x intercept is 4, 4 comma 0, and the y intercept is also 4 comma 0. So our line is passing through these 2 points. And also we can say that the origin is the point 0 comma 0 is satisfying by substituting origin 0 plus 0 is less than or equals to 1, which is true. So we can say that the solution, the shaded region is towards the origin. And hence we can say that this is a closed bounded, and the corner points of this closed region, the feasible region we can say, and the corner points are here origin 0 comma 0 and the point A 4 comma 0 and the point B 0 comma 4, and we can get the minimum value or maximum value at the corner points. Let us substitute in the profit function z is equal to 3x plus 4y. So here we'll get 3 into 0 plus 4 into 0, which is equal to 0, and here 3 into 4 plus 4 into 0, which is 12, and 3 into 0 plus 4 into 4, which is 16. So here we can find that at the point B it gives the maximum value, and at point origin 0 comma 0 it gives the minimum value. So the question, the maximum value of the z will give at the point 0 comma 4 and the maximum value is 16. So we can go with an option C. Let x denote the number of colleges where you will apply after class 12, and p of x is equal to small x denotes your probability of getting admission in x number of colleges, and it is given probability of at x is equal to small x is equal to kx if x is equal to 0 or x is equal to 1, or x is equal to 2 it is 2kx, and x is equal to 3 or 4 it is k times of 5 minus x. So here x is given the number of colleges, and probability of at x is equal to capital X is equal to small x is given kx and 2kx. So let us consider the table. For x is equal to 0, for x is equal to 1, for x is equal to 2, for x is equal to 3, and for x is equal to 4. Whenever x is equal to 0, that is probability at x is equal to 0 is kx, that is k into 0, which is 0, and at probability at x is equal to 1, which is equal to, we can consider kx again, k into 1, which is k, and probability at x is equal to 2, which is whenever x is equal to 2 we have 2kx, that is 2k into 2, that is 4k. So we can write 4k here, and probability at x is equal to 3, at x is equal to 3 we can write k times of 5 minus x, that is 5 minus 3, that is 2k, and next probability at x is equal to 4, which is equal to again k times of 5 minus x, that is 4, that is 5 minus 4 is 1k, and here we can note the sum of the probabilities is equal to 1. So we can just consider 0 plus k plus 4k plus 2k plus k is equal to 1. That is 8 times k is equal to 1, or k is equal to 1 upon 8. So the value of k is 1 upon 8, which is option B. For the curve root x plus root y is equal to 1, find dy by dx at the point 1 by 4 comma 1 by 4, that is at x is equal to 1 by 4, y is equal to 1 by 4. We need to find dy by dx. So let us differentiate this curve. Root x plus root y is equal to 1. Differentiating with respect to 2x, we have d by dx of root x is 1 by 2 root x, and again d by dx of this root y is 1 by 2 root y into dy by dx is equal to 0, or we can write 1 by 2 root y dy by dx is equal to minus 1 by 2 root x, or we can also write dy by dx is equal to minus 2 root y divided by 2 root x, or dy by dx is equal to negative of root y upon root x, and at the point 1 by 4 comma 1 by 4, so we can write negative of root of 1 by 4 divided by root of 1 by 4, so which is equal to minus 1. So dy by dx at the point 1 by 4 comma 1 by 4 is minus 1, which is option C. For what value of k the function f of x is equal to x power 3 plus x square minus 16x plus 20 upon x minus 2 whole square, for x is not equals to 2, and for x is equal to 2 it is equal to k, is continuous, function continuous for all real x. Since the given function is continuous, so we can say that limit extends to 2, f of x is equal to the functional value, that is f of 2, which is equal to k. So let us find the limit value at the function at x is equal to 2. So limit extends to 2, x power 3 plus x square minus 16x plus 20 upon x minus 2 whole square. By substituting x is equal to 2, we have 2 cube is 8 plus 2 square is 4 minus 16 2s are 32 and again 20. So 8 plus 4 12, 12 plus 20 32 minus 32 is 0, and again the denominator is also 0. So we can say this is 0 by 0 form. Since x is equal to 2 is satisfying the numerator, so we can just conclude that the numerator is x minus 2 is a factor. So let us use a synthetic division method to simplify it. So taking the coefficients, x power 3 coefficient is 1 and x square coefficient is 1 and x coefficient is minus 16 and the constant term is 20. Consider x is equal to 2 here. So initially you have to start with a 0. So addition 1 plus 0 is 1. Now we need to multiply 2 into 1, 2, that 2 be written here. So 2 ones are 2 here. Now 1 plus 2 is 3, and again now 2 ones are, 2 into 3, 6, that 6 to be written here. So minus 16 plus 6 is nothing but minus 10, and again now this 2 into minus 10, that is minus 20 should be written here. So we can get minus 20, 20 minus 20 is 0. Whenever you are getting 0 is a remainder, which means x is equal to 2 is a factor, and the remaining terms we can write. So x minus 2 into x square plus 3x minus 10, and we can also check that x square plus 3x minus 10 is 2 is again factor. So let us factorize it. X minus 2 into x square, and here we can write plus 5x minus 2x minus 10, or x minus 2 into x of x plus 5 minus 2 times of x plus 5. So we can write x minus 2 into x minus 2 into x plus 5. So here limit x tends to 2. The numerator we can write x minus 2 whole square into x plus 5 upon x minus 2 whole square. So we can cancel x minus 2 whole square, and limit x tends to 2 of x plus 5 is 2 plus 5, which is equal to 7. So the value of k is 7. Since the limit value is equal to functional value, so which is equal to f of 2 is also k, which is 7. So option A is the answer. If A is equal to a 2 by 2 matrix is given 2, 1, 7, 5, then find the determinant of A into adjoint of A. We know that determinant of AB is equal to det A into det B, and also determinant of adjoint of A is equal to det A to the power of n minus 1, where n is the order of the matrix A. So here we can write determinant of adjoint of A is A into det A into determinant of adjoint of A, which is equal to det A into det A to the power of n minus 1. So here n is equal to 2 because it is a 2 by 2 matrix. So we can write 2 minus 1, that is det A into det A to the power 1, that is det A whole square. So let us find the determinant of the matrix, which is equal to AD minus BC, that is 2 into 5 minus 1 into 7, that is 10 minus 7, which is equal to 3. And here the answer is det A whole square, that is 3 square, which is 9. So 9 is option B. So we can go with an option B. Assertion reason based question. Assertion: the minimum value of the function y is equal to cos x in 0 to pi is at x is equal to pi. Let us verify. Differentiate with respect to 2x. So we have dy by dx is equal to differentiation of cos x minus sin x, and again differentiating, we have d square y by dx square is equal to minus cos x. For minimum or maximum, we consider f dash of x is equal to 0, that is dy by dx is 0, that is minus sin x is equal to 0. In the interval 0 to pi, we can consider sin 0 is 0, x value can be taken 0, and again at x is equal to pi, sin pi and sin 0 0. And now substituting these two values, x is equal to 0 and x is equal to pi, in double differentiation, that is f double dash of x. Now f double dash of x is equal to d square y by dx square, which is equal to minus cos x, and let us substitute f double dash of 0 is equal to minus cos into cos of 0, that is negative 1, and f double dash of pi is equal to minus cos of pi. Cos pi is negative 1, so minus of minus 1, which is plus 1. So f double dash of 0 is negative, so where we can say that f has maximum at x is equal to minus 1. By the derivative test we can say, and f double dash of pi is 1, which is positive, so we can say f has minimum at x is equal to pi. So the minimum value of the function y is equal to cos x is at x is equal to pi, which is correct. So we can say that this is the function is having minimum at x is equal to pi. So assertion is true, and the reason the first derivative of the function is 0 at x is equal to pi. So we can say that the first derivative is equal to 0 at both the values x is equal to 0 and pi at x is equal to pi, and second derivative is negative at x is equal to pi is given, but second derivative is negative at x is equal to 0. So we can say the reason is false. So assertion is true and reason is false, which is option C. Assertion reason based questions. Assertion is given. The matrix A is equal to a 3 by 3 matrix. 2, 3 minus half 7, 3, 2, 3, 1, 1 is singular. And reason the determinant value of singular matrix is 0. A matrix is said to be singular if A is a singular matrix. We can say its determinant must be equal to 0. So we can say that the reason the determinant value of singular matrix is 0 is true. So reason is true. And let us check the assertion. A is equal to 2, 3 minus 1 by 2, 7, 3, 2, 3, 1 and 1. Let us consider the determinant, which is equal to 2 times of 3 into 1 minus 2 into 1, that is 3 minus 2 minus 3 times of leaving the row and column. We have 7 into 1 minus 3 into 1, 7 into 1 minus 3 into 2. So we can write 7 minus 6 and again minus 1 by 2 times of 7 into 1 minus 3 into 3, that is 7 minus 3 3s are 9, which is equal to 2 times of 1 minus 3 times of 1 minus 1 by 2 times of 7 minus 9 is minus 2, which is 2 minus 3 plus 1, that is 2 plus 1 3, 3 minus 3 is 0. So we can say that the matrix A is singular. So option A, sorry, assertion is true, and both assertion and reason are true, and R is the correct explanation of A. So we can go with an option A.